Welcome to 5-5 video. It's a fun one. So we've done triangle inequality things. So we're going to do inside a triangle this time. While a triangle is formed by three segments, there's a special relationship that happens. So the triangle inequality theorem says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So they color coded it, which is nice. So we have PQ plus QR has to be larger than the other side, PR, or for you color people, and if I can move this, that'd be awesome. The red plus the blue side has to be bigger than the green side. Then you keep going around, so we did red, blue has to be larger than green. So now blue plus green has to be larger than red, or with real things, QR plus RP, or I'll say PR because that's what I said last time, has to be larger than the other side, PQ. And if I mess up and do different things, it's all the same. And finally, so we did blue, green has to be larger than red. So now we're going to do green, red has to be larger than blue, or PR plus QP has to be greater than QR. So again, any two sides has to be larger than the third side. And if you hear random walking, that is my puppy. So yeah, listen for that along with me. So with that fact, we're going to do a quick problem. Is it possible to form a triangle with side lengths? If not, explain why or why not. So I like pictures, so I'm going to draw a random picture. I think that's chat also. So we have 8, 15, and 17. This does not have to be drawn to scale because it's just a representation. So again, two sides has to be larger than the third side. So what we're going to do, we're just going to take each possibility. So let's just start off 8 plus 15. That's a star. 8 plus 15 has to be larger than 17. And is 8 and 15 larger than 17? It is. 8 plus 15 is 23. So that's good. We're good there. Here, I'll put a check by it so you remember. That's a check. So next we have two other sides. Let's do 15 plus 17 has to be larger than 8. Is 15 plus 17 larger than 8? Yeah, it is. So we can check that one. And we have the third possible situation. 17 plus 8 has to be larger than 15. Is 17 plus 8 larger than 15? It's 25, so it's greater than 15. So that one works out. So it's a yes. So again, you check the three sides. As long as each case, two sides are larger than the third side, then you're good. I want you to try this one, and I'll have you answer that on your own. I'm sure you did wonderful. If the two measures of two sides of a triangle are 3 feet and 7 feet, which is the least possible number measure for the third side? So again, I'm going to draw a picture. Let's make this 7. Let's make this side 3. And then I'm just going to make this X. So we're going to try the cases where we're going to try every scenario and see whether these numbers would work or not. So I'm going to write out the three cases really quick. Let's just do 3 plus X has to be larger than 7. So again, I'm just going to 3X and 7. Then let's go X7 and 3. So we're going to have X plus 7 has to be larger than 3. And finally, we have 7 plus 3 has to be larger than X. 7 plus 3 is larger than X. And on your notes, you can change that to 10 has to be larger than X. So we are trying to find which is the least possible whole number measure for the third side. So we're going to start off. I'm going to plug in 5. Let's just start with 3. 3 for X. 3 plus 3 has to be greater than 7. Is 3 plus 3 greater than 7? No, that one doesn't work. 6 is not greater than 7, so we can already toss out A. So here, I'll cross it out. Oh, I did something. There we go. So it can't be that one. So let's try 4. 4 plus 3 is 7 is greater than 7. This one turned out really well. 7 is not greater than 7, so again, we can cross that out. And finally, we have 5. Is 3 plus 5 greater than 7? Yes, 8 is greater than 7, so let's go to the next one. Oop. 5 plus 7 greater than 3. Is 5 plus 7 greater than 3? It is. That's 12 is greater than 3. And finally, we can put a 5 over here. 7 plus 3 is greater than 5. It's 10, so that one works. So our answer is C. And I will circle it. Yay. So let's move on. I want you again to try this one. It's basically the same problem. They drew the picture for you, so give it a try. Way to go. And finally, we have everyone's favorite. We have a proof. So the distance from Colorado Springs, Colorado, to Abilene, Texas is the same distance from Colorado Springs. Prove that a direct flight to Colorado Springs is greater distance than a nonstop flight from Colorado Springs. So they do a diagram for you. CA is equal to CT. I already filled it in. It's given. And it's only 3 steps. I'll tell you that much. You won't get that on the quiz or test. So the final step is CL plus LT is greater than CA. So we're going to look at this. If we know that CA is equal to CT, well, there's another thing we know. How can we relate CA to CT in this triangle? If you remember the inequality theorem, triangle inequality theorem, it says that the two sides are larger than the third side. So if you notice, we have CL plus CT is going to be larger, LT. That should be LT. CL plus LT. I'm going to type it out. It's our next step. Pretend that never happened. CL plus CT is larger than CT. Oh my God, I said it wrong again. LT has to be greater than CT. So the two opposite sides are larger than the third side. And that is by the triangle inequality theorem. So if that's the case, we almost have what we're trying to prove. So the triangle inequality theorem, the two other sides have to be larger than the other side. If you notice, CA already equals CT. So the last thing we have to do is maybe you remember a thing called substitution. We can substitute one thing in for another if they equal. So we can substitute CA in for CT, and that's our proof. There will be a proof on the test, so if you have questions, please ask in class. Thank you. That was the lesson.